Hi, everybody. Welcome to a brand new episode of the Clear to Send podcast. I am your co-host, Roel Dionisio. And today we've got an interesting topic about Wi-Fi 7, MLO, and preamble puncturing. I think it's an interesting topic as we dive into Wi-Fi 7, which is coming up very, very soon. And so we have Arista here joining us on this episode to discuss how all of this works. So I will hand it off to Robert to introduce yourself and then Asvin as well. Go ahead, Robert.
Hi, my name is Robert Furlow. I'm a TME here at Arista Networks, and I'm happy to be with you today.
Thank you, Robert.
Hey, hello everyone. I'm Ashwin. I'm also part of Robert's team meeting. I'm very happy to be part of this podcast.
Awesome. Thank you for joining. And I'm really interested in this topic because it's something that I'm trying to learn a little bit more. It sounds like a complex, multi-link operation and what that means from a client perspective. And does that give us some benefits? So hopefully you guys can talk through that. And if you're listening to this episode, be sure to check out the video because there are slides to further kind of bring this topic makes more sense if you can see the visualizations that Arista is showing. So I'll hand it off to you guys.
So I'll get started. So we are going to talk about today on MLO. We will first briefly talk about different MLO modes, and we will also touch upon client behavior on the MLO. And we will briefly talk about preamble puncturing, how it works, and how efficient it is with respect to the legacy clients. And we will straight deep dive into the performance gains, especially EMLSR and STR-MLMR performance gain, and followed by effect of MLO on legacy client performance. And once we cover all of them, and we wanted to show you a demo which is having a spectrum view of STR-MLMR during active data traffic, followed by EMLSR during active data traffic. And we will also see a spectrum view of preamble puncturing in action. So these were the list of the packed agenda for the day. And we will quickly deep dive into the MLO modes. So MLO is one of the key features of Wi-Fi 7. As most current access points and clients incorporate dual band and tri-band capabilities, the newly built MLO feature enables packet-level link aggregation in the MAC layer across different physical links. By performing load balancing according to the traffic requirements, MLO achieves significantly high throughput, low latency, for enhanced reliability in highly loaded networks. Along with the MLO demo, we will also see how this MLO performance gains we achieve in the presence of interference. The MLO itself, by itself, we will see the behavior varies with respect to the interference. And that is something which we wanted to dig deeper in this today's session and see in which level of interference we actually see the gain with respect to this feature. Moving on, we have several solutions with respect to MLO modes. We have single radio solution, we have multiple radio solution. We have indeed tested across with the popular phones, mobile devices, which supports Wi-Fi 7 in the market. But mostly what we have seen is the clients either supports EMLSR or STR-MLMR. So we will dwell deeper into these two modes, and rest of the other modes we have not seen any clients outside out in the market which supports these two modes.
Okay, and I think that's interesting for people to know is how many modes there are available. There's 5 different modes, 2 in a single radio and 3 in a multi-radio. But what you're saying is with the clients you've tested, you've only seen 2 modes actually being used.
Yes, that is correct.
Okay.
So though we have these modes defined as per the standard, there are only 2 modes, which is like the single link EMLSR and multi-link EMLSR are the single radio solution. And today the recent client will not have this single link EMLSR per se. It is as per standard they support EMLSR, which is invariably multi-link by nature. And non-STR MLMR and EMLSR are two different modes. We have not seen any of these clients out there in the market,
Okay.
right?
Well, I
So
think single link. I think single link EMLSR kind of doesn't make sense anyway, since it's not. It doesn't sound like a multi-link operation.
yes, yes. Uh, So moving on, so in a very high level, this MLO modes can aggregate or steer data traffic across multiple bands without needing to do this four-way handshake. Is one of the key benefits of this MLO. We will see STR, MLMR, and EMLSR in action in coming slides. There's a high-level overview of STR, MLMR wherein in this mode we are able to concurrently transmit and receive over multiple links, meaning we will have one radio transmitting on 5. For an example, in this case, you will see one radio transmitting data on 5 gigahertz band and another can receive on 6 gigahertz band. So the client out there would have two radios, separate radios for different bands. That is STR MLMR in a very quick sense. In the case of EMLSR, we would actually see a steering benefit. In a previous case, we would see an aggregation benefit, right? So that is from a feature functionality perspective, that is a gain we get across these modes. In the case of multi-link EMLSR, um, what happens is the client, let's say this client is a 2x2, right? The multiple chain client splits its RX chain into 1x1 and listens on two links simultaneously. So as and when there is a data from the AP, so that's when the AP would trigger using an MU RTS and client would respond to it. And it then quickly switches all the chains to a single link dynamically and receive this downstream packet in two spatial stream, right? So, and then followed by the block ACK. And if it sends this CCAPC on one link, then it immediately sends the MURTS on the other link. So by this way, right, we are enabling dynamic steering across multiple links, which is a gain for latency.
Okay, and it's important to note that
So
MLO is really just to a single access point. It's not MLO to multiple access points.
Right.
right.
Okay.
So moving on.
There was a feature. There was a multi AP feature coordination that was not in this version of the spec, right? So that's something where you have coordination amongst multi. That's a different feature. We'll see if that happens in the second version of the spec rollout.
Okay.
From the MLO mode selection perspective, we did tested this behavior across having SSIDs in multiple modes. So in this case, when we have SSID on 2.4 and 5, we kind of see that client did STR MLMR on 2.4 and 5 efficiently. When we have an SSID on 2.4 and 6, we see STR MLMR in a formation across two links. And what we see with 5, when we have SSIDs on 5 and 6, we happen to see EMLSR in few clients, and some of the other popular clients doesn't efficiently form a EMLSR link. This is the kind of thing we need to know in advance, because the client ecosystem is quite important for the enterprise deployment. We need to clearly understand in what cases what mode would operate for this client. So in the last case, when we have SSID downloaded on all the 2.4, 5, and 6, these clients usually form STR MLMR in 2.4 and 6 or 2.4 and 5. But mostly it prefers 2.4 and 6 when we are operating in the US region.
I think it's interesting that 2.4 is preferred in this case rather than 5 and 6.
Yes, that is quite interesting observation we also noticed. So mostly the 5 and 6, because of the in-device coexistence interference, some of these clients were not efficiently doing the STR-MLMR, whereas they might have decided to do EMLSR in that case. But there will be an interesting observation. We have tabled across all the popular clients. We can go over each of these clients in the sequence and detail to understand what observation we have seen in our validation. So for the Google Pixel 8, when the SSID is there on 2.4, 5, and 6, we see the client does STR-MLMR, whereas when the SSID is in 5 and 6, we kind of see EMLSR. Whereas in the case of Samsung S24, we kind of see STR-MLMR in 2.4 and 5, 2.4 and 6, whereas it does single link operation. When we did that similar test on OnePlus, we kind of saw, so in pretty much in most of these cases, right, if we have SSID on 2.4, 5, and 6, it kind of prefer 2.4 and 5 or 2.4 and 6. But when we are having 5 and 6, that's when we kind of see mix of results. Some of them do EMLSR, some of them do SLO, some of them say it is MLMR, but data flow happens on 6. But the last client is quite interesting, which is a Qualcomm fast client 7800. So this is an HPS client which is having a multi-link capable adapter. So this was one of the client. It was able to form STR-MLMR in all possible combination, whereas in 5 and 6 also it was able to do efficiently the STR-MLMR case. So there are some clients out in the market where it does STR-MLMR, but it basically the client ecosystem is also evolving, and you might see a little bit of updates across clients, and mostly they tend to move towards EMLSR and 5 and 6 because these are the two frequency band which is closely packed together, and we need proper filtering and things like that.
So it's almost like in our designs when we're doing Wi-Fi 7, you really have to think if you want to have 2.4 enabled, because if you do, some of the clients will opt to choose 2.4 over 5 and 6, right? But it'll be interesting to see if they change the device manufacturers change that logic later on as 6 gigahertz matures a little bit more.
I think it has more to do with the filters that are in the client themselves, because without the proper filters, like with the Qualcomm Fast Connect 7800, that has proper filters, so that's why it can do high band simultaneous HBS. Otherwise, it wouldn't be able to do high band 5 and 6.
Yeah. So we're talking more physics stuff than anything, because it's such a small device. So the filters need to be very good, right? Like, and I wouldn't expect like a phone to have these really good quality filters for the Wi-Fi radio, and I guess maybe down the road that's what's going to happen. Bigger phones again, right?
Yeah, I wonder how big it has to be. Ashwin, the Qualcomm Fast Connect, how big is that? I remember the dimensions.
It's a normal client which would look like we kind of removed and put it into one of our laptops to do that test. But I don't think we have a kind of laptop model which comes with the default adapter.
Yeah, because to me that sounds like an adapter for a laptop, right? It's not.
Yes.
The Fast Connect 7800 is not a phone.
Yes.
Okay, that makes sense.
Yeah. So now we can move on to the new topic, preamble puncturing. In a very high level, preamble puncturing is a technique used in Wi-Fi communications to improve channel utilization and efficiency in environment with interference. What we see is two scenarios, one without preamble puncturing and with preamble puncturing. Without preamble puncturing, when a portion of a channel is busy due to interference, the entire channel width may be may be considered unused, right, leading to wasted bandwidth. So which means when there is an interference here, then the entire the channel width is wasted. Whereas in the case of preamble puncturing, by puncturing the busy part of the channel, the remaining portion can be used. Right? Thereby, it maximizes the bandwidth and improve the overall channel utilization. Right. So that is the benefit
Yeah.
of with and without preamble puncturing.
Yeah, I think preamble puncturing is interesting because, like you said, it's just creating a hole where the channel's busy, but still being able to use the rest of the channels in that channel width so that you can still get a higher throughput. And for me, it's what I'd like to see is how much of it is useful versus the overhead that it introduces as it tries to tell the client, like, hey, I can't use this frequency here, but we can use these, and let's negotiate to use that.
Right. So what we have seen in our internal testing is, and we also are planning to do at the end of this session, we'll do preamble puncturing in action. We will see. But once we have tested across different Wi-Fi 7 clients, we initially had few issues, but then over the period of time, I think the things are also improving. So especially when we puncture it, right? So these are some areas where we can do sniffing and check. In the EHT operation element, you have this disabled subchannel bitmap field that would get set to 1, and then we'll also see a bitmap there, right? That clearly identifies and tells the which part of the channel width it is punctured, and based on this Wi-Fi 7 clients would easily understand this information, and then it knows it should not be listening. There will not be any preamble or the data traffic on that particular punctured area, and that's when we get the full benefit of this feature. And the other legacy clients in turn would see would just block the secondary channel completely, right? So that is preamble puncturing in the beacons.
Yeah, I think that's a really good thing to show people as they try to troubleshoot or even identify, the SSID is present and what features are enabled. So if you really want to see that puncturing using Wireshark or even like Wi-Fi Explorer, you could create a column for this and be able to easily identify if puncturing is there.
Absolutely, yes. So now moving on to the EMLSR performance gain, we will be talking about, we will see how much of benefit does EMLSR offers in heavily loaded network, right? So we did a kind of simulated behavior test here, EMLSR. So most of the EMLSR gain will be seen when we actually start loading the network using some interference. Because some of the tests without interference, we do see some results, but this feature by itself will see a lot of benefits when you actually load the network, right? So in this scenario, what we have done is we have a EMLSR client associated to this access point. This is an EMLSR, meaning it can operate in both 5 and 6. And we have two clients here. They are 11AX clients. So totally there are 3 clients. The 6 gigahertz is operating in 80 megahertz and 5 gigahertz is operating in 40 megahertz. And we kind of started loading the 11AX clients with 50% load we did, right? We kind of induced the interference and we wanted to send a downstream TCP traffic and observe how this MLSR client behave with respect to this single link operation. So the one that you see on the blue is where it is a SLO, which is there's a single link operation. It can clearly see that EMLSR clients have have a higher throughput compared to SLO links. So when we tested, what we observed is we see 100% improvement in throughput and 45% improvement in the latency. Right. So those were the key takeaways here. Um, and from the Wi-Fi 7 client perspective, the significant benefit of EMLSR, it's kind of maintaining high performance even under the 50% interference load generated by the Wi-Fi 6 clients.
Okay. And so what you're saying is that the channel 5 and 6 gigahertz is being used by AX clients. And then the Wi-Fi 7 client also connected, negotiated MLO, decided to actively use both 5 and 6 to try to provide better throughput. Is that what you're saying? Or does it initiate it right away and use MLO right away, or only upon load?
No, so the main takeaway here is this test of 5 and 6 is not simultaneous. So which means the EMLSR clients are going to understand the traffic pattern, and if it sends that the 5 gigahertz link is overloaded, then it immediately going to switch to the 6 and start transmitting there. By that way, it kind of get the overall the steering benefits and aggregation benefit, and that resulted in a high throughput compared to the single link operation. In the single link case,
Okay.
when the throughput when the link is congested, right, it is actually going through the link congestion phase where it doesn't have much scope for throughput there, right, because it cannot switch to another channel.
Yeah.
Whereas in the case of EMLSR, it gets the benefit. It takes the benefit of using sensing which link is free, and it kind of transmitting the packets in that.
Okay.
And so you see the improvement not just in throughput but in latency, which is consistent. We generally see both improvements in both throughput and latency.
Yeah, much lower latency, like almost half, cut in half there for latency in some cases.
Yes. Yep.
Okay, that's
nearly
good.
50% of improvement in the latency. So we also did a test with a 70% load just to see how things are. We kind of consistently see high throughput, low latency pattern comparing to the single link operation. And quantitatively, we kind of see like 26% higher throughput at 70% load, and close to 40% in low latency.
Okay.
So with EMLSR gains 90% interference load experiment, this is a real client experiment we did, where we have a Google Pixel 8 connected here, and then both 5 and 6 gigahertz are operating at 80 megahertz channelization. And this time we kind of induced the interference close to 90% by having 85% of Wi-Fi interference and 5% of non-Wi-Fi interference induced in this environment. First, we kind of run EMLSR client the throughput test, and followed by the client operating in 5 gigahertz and 6 gigahertz separately for the single SLO operation. So what we see is um, uh, these two charts are a direct comparison. When we have 90% interference, on the 6 gigahertz, the EMLSR clients kind of sensed that and switches to 5, and we see the overall high throughput in this case compared to the SLO in downlink as well as this is uplink. Whereas in the second chart, what we see is close to similar behavior. When the interference is 90%, then the clients kind of switches from 5 to 6, right? So it basically tells us that whenever there is any transmission opportunity available, it kind of sends that and immediately switch and see the actual benefit here.
Yeah. So a total of looking at for downlink about 220 a 7% throughput improvement for downlink and 63% throughput
Yeah,
in uplink.
those are really big numbers, and
Mhm.
I wonder if this will change how we do capacity planning, right? Because now that we've got three bands and multi-link operation, um, and given it's a mixed environment, but with Wi-Fi 7 devices, they'll be able to pick bands based on what's available and still be able to get the throughput they need. So I wonder if that changes our capacity requirements and how we design for capacity.
Absolutely. Yeah, if you think about it, if you do the manual designs when we the old-fashioned way where you figure out how much each client needs, percentage of airtime they need for a particular application, given how many spatial stream the client has,
Yeah,
given how many spatial to the channel width and all that, right? Or if you use something like Hamina or Ekahau, whatever,
yeah.
to do that calculation for you, those calculations change. Yeah, for
Yeah,
sure.
and then you'd almost have to have a checkbox that says, yes, I'm using MLO,
Yeah.
and they'd have to do all that math behind the scenes to say, all right, here in this environment with Wi-Fi 7, you only need this many APs because you're tri-band and you've got, percentage of Wi-Fi 7 clients. And it'll be interesting to compare a Wi-Fi 7 design, high capacity to our previous designs without Wi-Fi 7.
Definitely going to change those calculations. As a matter of fact, we're going to have to update our design guides
Yeah.
to accommodate. Right.
You don't. Yes. So now moving on to STR MLMR performance gain. How much of benefit does STR MLMR brings to the table? Does the benefit holds good under high load condition is what we ran some test here. So in this case, we had one of our APs acting as a client in STR MLMR on 5 and 6 because kind of we don't have a reliable client to conduct this experiment. So that's why we kind of used this in our test. So here we kind of induced a 20% interference when 5 and 6 both are operating at 80 MHz channel width. And what we see with and without is we see uh, high throughput in both the case. And then with the interference, this high throughput still, I mean, we kind of see a very high throughput compared to the uh, compared to the SLO on 5 and 6 separately, right?
Yeah, that's
So
pretty
that is the
good,
key takeaway.
even with OBSS.
Yes, yes. So we kind of measured that. We saw 57% high throughput without interference and 63% high throughput with interference.
I think
That's kind of a very
this even shows how maybe meshing would perform because you're using an AP as a client, and I can see these meshing systems fully utilizing Wi-Fi 7 and MLO to make their equipment better, right? And I think that would make a huge improvement for even residential Wi-Fi.
right. And absolutely, yeah. It's a very interesting use case, though. Moving on to the effect of MLO on the legacy client performance. So in this test, what we did is we have a total of 30 clients, and then the MLO mode configured is STR MLMR, and in both 5 and 6 gigahertz are operating in 160 megahertz, and then 11 AX clients equally distributed in 5 and 6 gigahertz band, right? So what we are trying to do in this use cases, we know initially we are going to be in this phase, and over the next couple of years we will be here. We wanted to measure and see what if we have a 20% and 80% of client mix, right? Which means 6 clients in B and 24 clients in AX. With this, right, what is the effect of Wi-Fi 6 clients? Are they going to suffer? Or what is the effect of the Wi-Fi 7 clients when there is a mix of Wi-Fi 6 and Wi-Fi 7, right? So we kind of ran this test and kind of gradually, change the percentage from 20 and 80 versus 60/40 and then 70/30 and then moving to 90 and 10% percentage. And what we see is very interesting that the Wi-Fi 7 clients, that there is not much of throughput degradation in the presence of uh, legacy clients, in this case Wi-Fi 6E clients. But in a the another interesting find is even when we gradually reduce the Wi-Fi 6 clients, the density clients density, we kind of saw the improvement there, right? If you see this pattern keeps increasing. So it's not only that 11BE clients trying to steal some attempt from Wi-Fi 6E clients. It kind of understand the environment and fine tune, then do the opportunistic channel access and try to send a packet, try to use the link, and then that's kind of getting us the higher throughput benefit compared to the legacy. Even the legacy thing also, it's not drastically reduced when you
Yeah.
increase the
Yeah, I would expect
Wi-Fi 7 clients.
I would expect the Wi-Fi 6E clients to improve as you lower the amount of them, because it's lower contention on the AX portion. But with Wi-Fi 7, a little bit more efficient with how it's using the bands, right? So if those AX clients want to use 5, it'll use MLO to push maybe a lot of the Wi-Fi 7 clients to 6 gigahertz. But I don't know. It would be interesting to also see them with different RSSI values and how that would affect uh, upload and download as well.
Sure, yeah. So those are some of the experiments we need to conduct, as you suggested. But in a very high level, um, the overall impact here is the density of the legacy clients, especially 6E, does not impact the throughput of Wi-Fi 7.
Yeah.
And this highlights the efficiency of Wi-Fi 7 in managing channel access and maximizing throughput, even in the mixed client environment, is super cool. We'll have to conduct even more tests on different RSSI and see how much of the benefit we get overall, and try to have a best practice guide around that. Would be really useful for the deployment.
Yeah, it's good insight to see how we will transition over the next couple of years. I mean, even 6E is having a slow transition right now. So maybe we'll learn from the 6E transition as we go into 7, or maybe we'll see a bunch of people skip 6E completely and go straight to 7.
Yeah. So this is a similar pattern we see for the bidirectional too. Everywhere we see high throughput, low latency for enhanced reliability in a highly dense environment. And these are all the bit of efficiency we get is Wi-Fi 7 clients not impacted, as well as latency of Wi-Fi 7 clients not impacted by the legacy clients. So that is a kind of a very interesting client mix observation. Moving on to Wi-Fi 7 in our CDQ. So we do have an option we give to the end users to enable, disable MLO operations and MRU. We kind of highlight the configuration option. So by default, we kind of disable them. We wanted to see how the client mix are there in the environment, and gradually turn around for these features for the client. For the customers, they can just enable, disable for now and play around and see what kind of benefit they see on site.
Yep.
This is a
Could I
quick
mention too? Sorry, I just want to interject.
sure,
Roel, you and I spoke about this in the past. Like, where do you do that, right? And it's at the SSID level. It's not at the radio level, because it's a multi-radio thing. So you do it at as far as MLO and MRU, you do that actually at the SSID level.
Yeah, gotcha.
Preamble puncturing, we'll see later on that it happens at the radio level.
Okay.
radio level, yeah.
All right. I just want to mention that, we do have these switches or, additional nerd knobs for these features, the advanced Wi-Fi 7 features. And it's the same with Wi-Fi 6. if you think about OFDMA, MU-MIMO, right, we actually have switches for all of those. We don't want to have too many nerd knobs, but we want to give the customer the ability to enable certain features because
Yeah.
they don't always help, right? In some environments, those advanced Wi-Fi 7 features or Wi-Fi 6 features, they can actually, hurt performance. So we would like to give people the option, the customers the option
Yeah.
to.
I mean, it makes sense as people transition. Maybe they need to turn it off as they, so they can get newer devices in. So, I mean, it's a good thing to add.
Um, Moving on, this is a kind of a representation we have for the MLO. When an MLO client connects, we wanted to know whether it is connecting in SDR, MLMR, or EMLSR, and what are the band capabilities when they form the MLO operation, and also the kind of client and link view. If it is a client view, we kind of have um, the client, and in case of link view, we kind of map the MLT address to the client, where we kind of represent both the link addresses of their band capability, right?
Yeah.
So
I
all
think
of
that's
those are,
critical. That part's
yeah,
very important because it's not the same MAC address being used for
yes.
both links. And I think that's important for people to know as they learn about MLO. You'll see two entries. So it kind of looks like you have an inflated count of clients because of that.
Yes, inflated count of client, yeah. So, yeah, so this stats is mostly of EMLSR mode, where there also we kind of represent two links, MAC address, and etc. Moving on to the preamble puncture, similar to Robert mentioned, we also have this preamble puncturing. This time it is on the radio level. We can enable disable feature, enable them, and see the benefits of the feature. So here is a quick screenshot of what happens when it is actually punctured. We kind of represent them. This is the area where it is actually punctured, and then we do say the puncturing status in our UI, like which block of it is punctured and what is the status of that AP, whether it is running in full channel width or it is running in punctured width, for the end user to know it is actually operating in punctured channel. So from the troubleshooting perspective, we also built the client packet trace. We have three different modes now. One of the AP we are talking about is the 460. It has the fourth radio, which is a multifunction radio, in addition to the 3-axis radios, which is operating in 2.45 and 6, where we can take one of the fourth radios and do make that as a sniffer and then sniff the packets over the air in whichever channel that we want. And then we kind of introduced two different packet capture mode. One is the access point inline mode and promiscuous mode. In inline mode, is super cool feature wherein um, we kind of when the Wi-Fi 7 clients are associating, right? When it transmits packets in both the links, when we do this capture, we kind of capture them in both the links simultaneously and put them in a single packet for us to easily debug it. The other option is we have accelerated promiscuous, which is also an inline capture, but then it just not only captures your associated SSID packets, but it too captures the other packets seen over the air too. So that is where this will also come handy when some of the product line does not have the multifunction radio. They can actually use this feature to get the benefit of overall sniffing across different bands.
Yeah, thank you for adding
So
those
this
options
is,
because once you're troubleshooting MLO and you're not capturing on the right channel, you may think some packets aren't going through. But if you capture it at the AP level and combine those packets for us, we can then see if the traffic is indeed going through the AP and receiving traffic to the AP. So it's a good troubleshooting option.
Yes. That would come handy when we actually troubleshoot. It also decrypts the packet for us. Since it is an inline capture, we know what keys are being used, and at the time of sniffing, right, we kind of decrypt the packet. That would actually, from a troubleshooting point of view, it would be a very useful feature. So, moving on to the demo. So we wanted to cover these three scenarios: the spectrum view of STR MLMR during active traffic, MLSR, and preamble puncturing. So let me quickly pull up. Yeah. So in this test, what we have is we have a ICAO spectrum analyzer plugged into a laptop, and we also have Google Pixel Pro connected to the same laptop, and we are seeing the Google Pixel Pro using a Wi-Fi app running on that laptop. So what we are trying to do right now is we enable the Wi-Fi, we connect to one SSID. Once it's connected, we kind of like go inside the properties and check if it is 2.4 and 6. So this particular test is primarily for STR MLMR. In the right side, we see a spectrum analyzer. We are like navigating across different 2.4, 5, and 6. There is not much of energy there. As in when you start the test, what we see is the spike of energy observed in 2.4 gigahertz, right? This shows that the packets are going in 2.4. There is not much of energy detected here, but 6 gigahertz, again, you see a very high intense energy because there is a speed test running on this AP, right? As in when you stop the test, what we see is the energy drops on both the links. So that kind of is a cool demo to tell that this is an STR MLMR transactions are happening, and the Google Pixel and RUI can show both link view and client view, right? So this is one test on the STR MLMR on the spectrum view, accessing both 2.4 and 6 gigahertz. The
Yeah, that's an
second
interesting test.
demo that we want.
Trying to capture that
Yes,
on the
that is.
spectrum, you gotta toggle back and forth to see what's happening.
Yeah. So in the second test is this. In this test, we have SSID only on 5 and 6, but the client is same. It's plugged into the ICAO is also plugged into the same laptop. What we see is this time it's connected to an EMLSR SSID. Now the frequency is indicated as 5 and 6. We will when we run the speed test now. Before we do that, we'll quickly check the 5 gigahertz and 6 gigahertz spectrum. There is not much of activity there. Once we confirmed the activities are not there, now we can run the test. The test is running, and then we start seeing energy sensed in 5 and 6. In this case, it is doing band switching across two links. And what we see is the packets flowing across 5 and 6. Right?
Yeah, that's cool.
And once we stop the test, we see the
energy goes
the
away.
energy goes
Okay.
away.
And you said this was a Pixel phone?
Yes, Google Pixel 8 Pro.
Okay.
And we also have this client view and link view to represent, we kind of detect them and then show them in our UI.
Mm-hmm. Yeah, that's good to see. Like, okay, is what channels are my multi-link
yes.
operation client connecting to?
Yes, and not only that, you will also be able to see how much of packets being actually sent in 5 gigahertz and 6 gigahertz exclusively. That will also come handy if you see in some of the tests we kind of load the interference to 50-60%. in that case, which link is being overutilized and things like that, we should be able to easily spot it out in our UI.
Okay.
And I should mention that, I was trying to get Ashvin to use our spectrum analyzer for this test because our APs are the tri-band spectrum analyzers, right? The multifunction radio can do it, but the resolution is not as good as the Sidekick. I mean, it stands to reason, right? Because it's a special built product, the Sidekick too, opposed to the
it's meant to
multifunction
do
radio.
spectrum.
Yeah.
No, it's a good example. I think it's really neat to see multi-link operation working, and even using a third-party tool to show that it's pretty neat.
Sure. So moving on to the last demo where we wanted to show the preamble puncturing. So in this demo, we will be associating to an SSID that has like 2.4 and 6, which is strMLMR, and we will we'll run the same test where the speed test. Before running that, we kind of see there is not much of energy on 5 and 6 and 2.4 as well. And then when we ran the test, now the energy would get seen on the 6 gigahertz. And now what we intend to do in this test is we kind of induce an interference, and our AP would detect the interference and start doing the puncturing,
Oh
right?
wow,
As you
there he
see
goes.
here, when we induce the interference and then there is a punctured, and then the client does not disconnect in this case, but it continues to operate in 20 megahertz as against
you
to
see the throughput
here and there
drop a little
160
bit, but
megahertz.
it's not a significant drop. Well, let me ask you this,
It's not
because
a
6
significant.
gigahertz, there's you've got incumbents on 6, and let's say using AFC, like that specific channel has to be given up for the incumbent. Would that work as puncturing as well? Like could in puncturing, could it just say, all right, I'll take that channel out? I guess it's really an AFC question, but I was just curious if
I don't have the answer for that question. But invariably we have an interference threshold. We did have parameters for Wi-Fi and non-Wi-Fi thresholds and radar hits, and then based on that we kind of take them into account and decide whether to puncture that channel or not.
I think that's a really cool feature to see working, and there's already clients out there that support it, and I guess it's just a matter of more mass adoption.
Yeah. So with AFC though, like you that channel, like you're in an area where that channel already being used by an incumbent, then that would just be a channel you couldn't use, as opposed with preamble puncturing, it would be a channel that is available, but then there's a high enough interference to cause the puncturing right above a threshold.
Okay.
Yep. And
And is puncturing only in the 6 gigahertz, or would it also occur on 5?
It would also occur in 5.
Okay.
So this particular experiment we did for 6, but certainly you can, in 80 megahertz channel width, you can puncture any of the secondary sub-channels. And then
Because I'm wondering then if, again, it goes back to design, right? Like if we have tri-band and Wi-Fi 7, could we on 5 start increasing our channel widths, especially with puncturing being available?
Yeah, that was my main question too when I started thinking about this feature. And I mean, if it works the way we hope it will work, it means that you could start designing with wider channels, because you wouldn't. Yeah, because you're gonna opportunistically, you'll be able to use 75% of the wider channel, right?
Yeah.
If 25% is not available. But we'll see. We have to do more testing, and again, it will influence our design recommendations.
Yeah. You got a lot more tests to do, because you showed with the interference right on 6 gigahertz and how that the throughput works, upload and download, and then especially with puncturing. It'd be interesting to see the same on 5, since that's what's going to be used more in the next few years as we transition. but I
Yep.
guess we'll see more realistic numbers in the future. It's just a good example of what's to come and what we should expect with these Wi-Fi 7 features.
Right. Yep. Yeah. And definitely looking forward to doing more testing and helping us, guide our recommendations. Oh
Awesome.
yeah. So if you want to learn more, we have a link up there now for webinars where we will talk about these type of findings as well as many other topics. So there's at the Arista website, you can find out how to sign up for some webinars.
Awesome. I'll
I
include
think,
the link over in the show notes so people could click on that and sign up if they want to see more.
yeah. Let's see. Any other questions? I think we covered everything we wanted to cover.
Yeah. I guess since you were testing with the Wi-Fi 7 AP, is that already available for people to purchase, or is there a future release date on that AP?
Yeah, I don't it's imminent that they will be available for purchase. I do believe we're looking at September for GA, or is it your best your recollection, Ashwin? Um, do you remember what the
Yeah, it's
GA is?
somewhat around there. Yeah.
Somewhere around
Yeah.
there.
So
It would be the
yeah.
C460. It's our first Wi-Fi 7 platform. It's a four radios, four Wi-Fi radios total. But three are for access. One is that multifunction radio. And we did a whole series, a whole webinar, a CTS podcast on the multifunction radio. Yeah, so that's our first and it's our flagship product. And that I think it's going to be available to order very shortly if it's not yet on our price list. And then to be followed by, rounding out the whole Wi-Fi 7 family. But we haven't announced any other of those platforms just yet.
Okay, great.
Yep.
Yeah. Well, thank you for joining this podcast here to share MLO and your findings of how it works, especially with the puncturing. I think Wi-Fi 7's starting to look pretty good. Of course, we'll wait until we start seeing more clients and some real environments, but your initial testing is pretty insightful. And I think it will let people understand how they should approach this upgrade to Wi-Fi 7 and what they should expect with the features. So I want to thank you guys for joining us and sharing a lot of this information.
Thanks for having us. Been fun.
Thanks
Looking
for
forward to the
having
next
us.
one.